Ladies and gentlemen, a warm welcome to you all are hearing. My name is Mohammad Faiz and I'm honored to stand before you alongside my partner, Ahmed Hussain. Together we extend our heartfelt gratitude to our esteemed university Keat for their unwavering support. We would also like to express our sincere thanks to our advisor, Mr. Dr. Taha, for their invaluable guidance and mentorship. We acknowledge the esteem of journey, Ms. Misbah, this movement for their valuable insights and expertise. It is through the collective efforts of all involved that we stand here today. Ready to host this momentous event, we have put in dedicated efforts to ensure a memorable experience for you, and we are thrilled to have you join us as we celebrate, connect, and inspire together. Thank you for being part of this special occasion, and let us make it truly extraordinary.
Hello, here Emerson. Further, we started, as we know, health is characterized as a full state of physical, social well-being, and not merely a lack of illness. Health is fundamental element of people need for better life. Unfortunately, the global health problem has created a dilemma because of certain factors such as poor health services, the presence of large gaps between rural and urban areas, physicians and nurse unavailability during the hardest time. The problem with traditional health monitoring method lies in the lack of real-time monitoring, inconvenience, limited accessibility, fragment data collection, and reliance on manual interpretations. To overcome these challenges, the Smart Health Monitoring System offers a solution that enables continuous real-time monitoring of virtual health parameters.
Now, let me introduce our project, the Smart Health Monitoring System. The inspiration behind this project stems from a common problem faced by many individuals, the need for a reliable and efficient methods of monitoring one's health, particularly in the context of cardiac health. We recognized the importance of real-time monitoring and early detection of potential issues such as irregular heartbeats or arrhythmias. Therefore, we set out to develop a system that could provide accurately and timely insights to an individual's heart's health. The flow of our projects begins with the acquisitions of electrocardiogram signals using the AD8232 sensors. These sensors captures the electrical activity of the heart, allowing us to gather essential data for analysis. Subsequently, we employ the with different algorithm are widely recognized and effective methods to process the ECG signals and calculate the vital parameters such as heart rate and many other circumstances. These parameters provides valuable insights into the functioning of the cardiovascular systems and enable us to detect abnormalities or irregularities. Here are the NodeMCU and data acquisition from the 88232 sensors through which 88232 sensor retrieve data by the NodeMCU, and at the meantime, NodeMCU sends the data to our cloud system on a local server, and local server pre-process, and their result will be shown on the web application or desktop application. Here are the locations where we locate the, for example, our right probes will be located on the right hand side of our body. Our yellow probes will be located on our slightly left on to the our heart position, and green probes will be located just upside down to the where we located. Functionality Smart Health Monitoring System. We have developed a local Flask server that hosts our application as you can see in the screen. Here are the code demonstration you can see in Python language we followed in this project. Further, we move on to our desktop application. Through this user-friendly interface, we showcase the various functional features. Here are the crucial parameters of ECG signal that we calculated from our Pan-Tompkins algorithm that we followed to calculate R to R interval and heart rate. Here we call the user connected their probes to their desired location, and hence the output waveform will be generated in that way. As we discussed earlier, users can view real-time ECG waveform, observe their calculated heart rate and RR distance. System retrieve 10 seconds of data after every 2 seconds in the ECG live plot graph, ensuring a continuous and comprehensive monitoring experience. From anywhere of the world, user can just locate probes to the desired location, and therefore these data on a meantime can view on the patient screen as well as on the doctor screen. In part on the second, I can explain the doctor dashboard on which the user data can experience as we collected from through user panel. Further, we move upside down. We have received ECG data critical parameters calculated through our Pan-Tompkins algorithms. With the help of Pan-Tompkins algorithms, heart rate are the major parameter that we have calculated. RR distance are the two mean interval distance between peaks that we have received from the patient's data. These are further diagnosed elements for doctor prescriptions. Further, we move. Here are the prediction of disease classification that we have received from patient's data. Here we classify disease into 4 parameters. Number 1, normal. Number 2, SVAB, which means supraventricular ectopic beats. Number 3, ventricular ectopic beats. And F is just fusion beats. Here are the glimpse of code. Here front end and back end both are based on Python language.
We here the panflex of our FIP of our project, which consists of abstract, and this is the key features of our panflex, which consists real-time monitoring, remote monitoring, data visualization, low power consumption, and data expansion reports, which we have in our FIP. And this is our hardware implementation data acquisition system. And this is the dashboard of our project. Further, we move on the FIP reports. It is our abstract to summarize the project. And here the first diagram which is use case, and the second diagram is activity diagram, and the third one is most important, system architecture, which consists of, first of all, user can enter the data 8233 module, and it is going to NodeMCU to acquire the raw ECG and to send to the local host and any clouds, which is Firebase, and these all the data is going to web app, which is accessed by the patient and also the doctor. Now it ends our project. Thank you all of your presence and support.